Hi, everyone. Today we are going to start a new chapter about coordinate geometry. We're going to be investigating, discovering, and proving things about geometric figures that are on the XY plane. So let's get started. So today we're going to talk about distance, midpoint, and circles. Our objectives is to rediscover the distance formula, write equations about circles, and put them in standard form. Basically, that includes completing this square. Identify the center and radius of a circle from standard form. So we're going to start off with the distance in circular formula. This right here is a graph, and you just are supposed to write on this graph, what it is that like what's the origin. So in this case, the origin is this point 0, 0, which happens right here. So anytime where your x and your y axis cross, that's your origin. Your axes, you have an x-axis and a y-axis. So this is your x-axis, and this is positive x, this is negative x-axis. This is your positive y and negative y-axis. But the whole thing is called the y-axis. When you're talking about a scale, they're just talking about the unit. So like if you move over 1, this is 1 unit, 2 units, 3 units, etc. But sometimes you can move over 2 places and call that 1. And then 2 more places, that would be 2. So it depends what you're scaling. You're scaling, how do you want to scale your shape? What do you want it to look like at the end? And lastly are our quadrants. And this would be our first quadrant. Moving to the left, that's our second quadrant. Down, this is our third quadrant. And here would be our fourth quadrant. That's based on starting at the x-axis, let's say 0 degrees, moving across. There's 90 degrees, keep going, 180, come down, 270, keep coming up, all the way around, circle, 360 degrees. Anyway, so those are our quadrants based on starting at 0. So to start with, we're going to plot these points and try to find the distance between them. So anything horizontal or vertical, okay, it's going to be pretty easy to be able to find the length between them. Obviously, you're not going to be finding the length of a line, but if it's a segment, as these are, that's what we're going to find. So we're going to start at over 3, up 2, 3, 4. So here's the point 3, 4, and I would recommend that you put all this on graph paper, you label your points. Part B, or point B, is going to be negative 1, 1, 2, 3, 4, and there's this point here, and there's point B. So your job is to find the distance between these 2 points. And so very simply, you can count over 1, 2, 3, 4. So my distance here is equal to 4 units. And you could say 4u for 4 units, or you can just say 4, etc. So that's 4 units around. So then we have CD. So I'll use blue for that one. So that's going to be over 1, 2, 3, negative 3, 1, and then we have negative 3, negative 2. So the distance between this vertical line, count 1, 2, 3, is 3. So my distance equals 3. Now, for these two, these are pretty simple just to count the distance between the 2 points. This was the point C, this is the point D, but the distance between the 2 is this counting distance here. So again, vertical and horizontal lines are really easy to find the distance. What gets a little bit tricky are these points right here. So let's graph these. So what we have is 4, negative 2. So we're going to start with 1, 2, 3, 4, down 2. So we're going to put a point right there. That's point E. And then we have point 1, 2, which is right here. So that's E or F. Okay. And what happens is, I'm going to move the E over to the other side down here. And so what ends up happening is we end up with this point between this distance between the 2 points, like right here. Okay. And our job is to find the distance there. But the problem is this is not a vertical line and it's not a horizontal line. So one way to find that is to use what we call the distance formula. Okay, so this is the point 4, negative 2, and 1, 2. So the distance formula is something that you did in Algebra 1. It says the distance between 2 points is the square root of the second x minus the first x quantity square that, plus the second y minus the first y, and quantity square that. Now, if I were to do that, I would say, well, the distance is equal to, and then I would need to subtract my x's. It doesn't matter whether you say 1 minus 4, and then 2 minus negative 2, or if you say 4 minus 1, and then negative 2 minus 2, and I'll show you the difference, because there is no difference. Either way is okay as long as you are consistent when you subtract. So we're just going to say 1 minus 4. So we're going to start with that. So we're going to go 1 minus 4, quantity squared, plus, now I'm going to go 2 minus negative 2. So parenthesis 2 minus negative 2 squared. So what that becomes is 1 minus 4 is negative 3, but negative 3 squared is 9. So this is the square root of 9 plus, and then 2 minus negative 2 makes plus, so that's 4. So 4 squared is 16. 9 plus 16 is the square root of 25. Square root of 25 is 5. And that's my answer. A couple of things that I want to just stress, and so that just ahead of time so you don't make this mistake later. The square root of 9 plus 16, it does not equal the square root of 9 plus the square root of 16. If you think about it, this right here would be 3 plus 4, which is 7. That is not the same as saying 9 plus 16, which is 25. Square root of 25 is 5. Those are not the same. So you never break this up into two parts. The only time where it would be okay to break those up into two parts was if you were multiplying, like the square root of 6. Well, that could be written as the square root of 2 times the square root of 3. That would be okay. But you don't break them up like this. Okay, so I'm going to erase this because ultimately what I want to do is show you the other way for subtracting these. And that would be, let's see, if I were to go 4 minus 1. So let's do it this way. The distance between the two points would be calling this x1. So we'd go 4 minus 1. So 4 minus 1 quantity squared plus, and then you'd say negative 2 minus 2. So it'd be negative 2 minus 2 quantity squared. So that's 3 squared, which is 9, plus negative 4, which is squared, 16. 9 plus 16, the square root of that is 25. So either way, you're going to get the distance is equal to the square root of 25, which is 5. Now, there is actually another way of solving this and finding the distance between these 2 points. Okay, right now, we know that that distance is 5. However, I could have simply made this into a right triangle, okay? And if you did that, you would notice that this distance here was 3. This distance in between here was 4. And you could say 3 squared plus 4 squared equals that distance squared. 9 plus 16, which is 25, and then square root both sides, and then you have x equals 5. So there are multiple ways of finding the distance between these 2 points, okay? So this is where this came from, the Pythagorean theorem. The distance formula comes from the Pythagorean theorem. Basically, you have these 2 points and you want to find the distance between these 2 points. What you're really doing is you're making this, and you can make this into a right triangle completely fine, and you would be counting those points. However, you're finding the distance between those anyway to find the horizontal, what is that? The hypotenuse, okay? So you would find this length here, and then you would find this length here. So what is that length? So let's say 1, 2, 3, 4, 5, 6. That looks like 6. And this length looks like it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that looks like it's 10. Does that look like it's 10? Okay. So to find this side right here, we would say 6 squared plus 10 squared is equal to the hypotenuse squared, which would be 36 plus 100, which is 136, is equal to x squared. So x is equal to 136, the square root of 136. finding this, another way of doing that is just to use the distance formula, which is x sub 2 minus x sub 1, quantity squared, plus y sub 2 minus y sub 1, quantity squared, and the square root of that is the distance. And that became from distance squared equals this value. So anyway, that's where the Pythagorean theorem comes from. On any of the distance formulas, you can use the Pythagorean theorem, unless in your lesson I'm asking you to specifically use the distance formula to solve. So what we have here is the 3 vertices for a triangle, ABC. So let's graph those points. We have 1, 2, 3, negative 3, 1, 2, 3. So this point is A, and that's negative 3, comma 3. We have B, which is 0, 7. So 1, 2, 3, 4, 5, 6, 7. Okay, so that's B, 0, 7. And then you have C, which is 5, negative 5. So 2, 3, 4, 5, 1, 2, 3, 4, 5. So connecting these points, what we have is a triangle. Okay, and what we want to do is to find the perimeter of this triangle. And this is C, which is 5, negative 5. So if we want to find the perimeter of this triangle, okay, what you need to do is you need to find the distances between each of the sides. So this is 0, 7. Okay, that's a little bit weird, so I'm going to just fix that. So 0, comma 7. All right, so in order to find the distance between, let's say, AB, okay, so we're going to find the length of AB, then what we're going to do is we're going to subtract our x's. So I'm going to go negative 3 minus 0, so this 3, negative 3 minus 0, quantity squared, plus 3 minus 7, quantity squared. So that's negative 3 quantity squared, which is 9, plus 3 minus 7, which is negative 4. Negative 4 squared is 16. 9 plus 16 is square root of 25, which is going to be equal to 5. So this distance right here is 5. Okay. For this triangle here, we're going to use the distance formula again. So that's going to be BC. And so that's going to be the square root of the distance. So we're going to say 0 minus 5. So parentheses, 0 minus 5, quantity squared, plus 7 minus negative 5, quantity squared. 0 minus 5 is negative 5. Negative 5 squared is 25. This makes plus, so that's 12. 12 squared is 144. 144 plus 25 is the square root of 169, which is 13. So that's BC. Okay, so that was fine. This segment is measurement is 13. So that distance equals 13. And then the last distance is for AC, and that's going to be the square root of negative 3 minus 5, quantity squared, plus 3 minus negative 5, quantity squared. So that's going to be negative 3 minus 5 is negative 8. Negative 8 squared is 64. These make plus 8. 8 squared is 64. So what we have for length AC is the square root of 128. Keep in mind that you should try to reduce when possible. That's going to be square root of 64 times square root of 2. So that's going to be about 8 root 2. Okay, so that's the length of AC, which is 8 root 2. Okay. I do want to say one thing in that, remember, I could have made these into right triangles. And if that was the case, then going back up, that's a right angle here. And then this little triangle would be this right here. So you do have a rectangle there, of course, with your right angles. That's another way of finding the distance between the 2 points. So same question, but I am asking for the midpoint. So let's go negative 3, 1, 2, 3. So again, we have point A, which is negative 3, 3. We have B, which is 1, 2, 3, 4, 5, 6, 7. So this is the same picture. So this is B is 0, 7. And then we have 5, negative 5. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, and that's C, which is 5, negative 5. And so connecting these points, okay, here we have this, and then we have this, okay? And so what's happening now is you're trying to find the midpoint between the 2 points. Instead of finding the distance, we're looking for the midpoint. And so we do have a midpoint formula, okay, that you could use, well, you will use, and that's going to be to find the midpoint between any 2 points. You could say points XM and YM, standing for midpoint. You would, here's the formula, add your X's, divide by 2, comma, add your Y's, divide by 2. And what you're doing is you're simply just finding the average of those 2. So what we're going to do is we're going to find the midpoint of, so we're going to find the midpoint for AB. And so that's going to be adding my X's. So I'm going to go negative 3 plus 0 divided by 2, 3 plus 7 divided by 2. So negative 3 plus 0 is negative 3 halves. So this is going to be equal to negative 1.5, comma, 10 divided by 2, which is 5. And if you look at it, what you see is technically negative 1.5 and then up 5 does look like the midpoint. And that's what that is, okay? The next one we're going to find is the midpoint for BC. So in order to find the midpoint for BC, we're going to go BC. We're going to go 0 plus 5, divide that by 2, comma, 7 plus negative 5, divide that by 2. And you're going to get 5 halves, which is going to be 2.5, comma, and then 7 minus 5 is 2. 2 divided by 2 is 1. So then we have the midpoint at 2.5, 1. So that's about right there. They wanted the midpoint, find the length of the median. Well, the length of the median is the distance from here to the midpoint. So now I need to find the midpoint of AC. So in order to find the midpoint of AC, again, I'm going to go negative 3 plus 5. So negative 3 plus 5, divide that by 2. Then I'm going to say 3 plus negative 5, divide that by 2. So that's these 2 points is what I'm adding. And so what I get for the midpoint is 2. Negative 3 plus 5 is 2. 2 divided by 2 is 1. And then this is going to be negative 2 divided by 2, which is negative 1. So 1, negative 1. So 1, negative 1. So this value, 1, comma, negative 1, is the midpoint of AC. Now, this says find the length of the median. Now, we all know that the length of the median from point B to AC is the point that goes from the vertex to the midpoint. So that's the midpoint, or excuse me, that's the median. So in order to find the length of the median, I'm actually going to use the distance formula, and I'm going to say the distance from this midpoint here to the point B, the vertex. I'm going to use distance formula. I'm going to say distance equals 0, parentheses 0 minus 1, quantity squared, plus 7 minus negative 1, quantity squared. So we get, 0 minus, this is 0 minus 1, which is 0 minus 1 is negative 1. Negative 1 squared is 1, plus 7 minus negative 1, which is 8. 8 squared is 64. So keep in mind that that's the square root of that. So the distance of that length from here to here, from B to M, is the square root of 65. And if you had to approximate that that length, it's going to be about, I would say, like 8.1, because that's like the square root of 64 plus a little bit. We're moving on to circles, and circles basically are based on a formula that I'm going to talk about. So here's a circle. Let's say this is my radius. Of course, that's also my radius. There's infinite radii in a circle. This point is 0, 0. Based on this point and this length being r right there, which is the radius, based on that, you would have an equation given that hk is a center, okay? You would say that the formula for writing this would be x minus 0 in this case, because that's my center, quantity squared, plus y minus 0 quantity squared would equal my radius squared. Now, let's say I said my radius was 7. This makes this equal to 7 squared, which is 49. So I would be writing x squared plus y squared equals 49, just simplifying with the zeros, and that would make that the equation of my circle. Likewise, if I said I had another circle, and then this radius, let's say, which is all the way around, and I know it doesn't look even, but let's just say it is. Let's say my radius is 4. And it was still at the center at 0, 0. The equation for that would be x squared plus y squared equals 4 squared, which is 16. Now, what happens is when you move that center off 0, 0, okay? Let's say you moved it over. Let's say my center was now at 2, 1. And let's say that's my center. And then let's say from there, my radius was, let's say 3 all the way around, okay? So my radius was 3, and the center of my circle was over at 2, 1. Your new equation for that would be, because you're subtracting x minus 2 quantity squared plus y minus 1 quantity squared is equal to r squared, which is 9. Now this right here comes from this formula, given that hk is my center, and here's hk, that you would have x minus h quantity squared plus y minus k quantity squared is equal to my radius squared. So this right here is standard formula for my circle. And so a circle being a set of all points that are equal distance from a given point called the center, and we're going to call that's my center. We represent the center of the circle as hk. So this point is h comma k. The equation of the circle is going to be x minus h quantity squared plus y minus k quantity squared is equal to my radius squared. And so if, again, I said that x minus 2 quantity squared plus y plus, let's say, 3 quantity squared equals 5, the equation of what my circle would look like would be a center at 2, negative 3, and this is r squared. Actually, I'm going to call this, oops, hold on one second. I'm going to make this 25. So this would mean my radius is equal to, so if this equals r squared, so r squared equals 25. So if you square root both sides, you get r is equal to 5. Okay, so our center is at 2, 3. So over 1, 2, 3, no, over 2, down 3. There it is right there. And then I would go 5 units to the left, 5 up, 5 down, all the way around, and then that would be my circle, okay, with radius 5. Just keep in mind that this right here is my standard form for my equation, and you'll notice that, see how it says x minus h? That's actually the opposite of h. So this, see how 2 is positive? When you say the opposite of h, that makes the 2 negative here. And this says the opposite of k, which makes my negative 3 now positive 3. So just keep that in mind. That formula is actually saying the opposite of this and that. So what is the equation of a circle that has a radius of 2 and a center of 5, negative 3? So 5, negative 3 is about here. My radius is 2, so I would go 2 all the way around, and I would have a circle there. The equation is going to be, the parenthesis, x minus 5 quantity squared. Remember, it's the opposite. Plus y plus 3 quantity squared is equal to my radius squared. My radius is equal to 2, so radius squared is going to be 4. And this is the standard form for the equation of a circle. Now, for this problem right here, it says, given the equation, what's the center? Well, the center, opposite, opposite, so that's going to be -3, 2. And if this right here is equal to r squared, and you were to square root both sides, you're going to get the radius is equal to 5. You just need to be careful because occasionally what's going to happen is, let's say I had x squared plus y minus 2 quantity squared equals 13. And so here's my equation. It's a different equation than the example right there. But let's say that I asked you for the center. Well, the center for this equation is going to be 0 because this right here is actually x minus 0 squared, comma 2. And my radius is going to equal the square root of 13, not 13 or 13 squared. It's going to be the square root of 13. Because remember, this is equal to r squared. So you're going to square root both sides. You get r radius is equal to 13. Square root the root. Now, I've had several questions about roots and whatnot. And I just want to go over one thing, and that is when you have, let's say, the square root of, 49. And if you have the square root of 49, a lot of people have been asking, well, why do I square this and I just get the same number? Why does that happen? What's happening is you're taking this, or even, let me start even before that. Why do I get, for the square root of 49, why do I get 7? And the reason for just this is the square root of 49 is actually, can be rewritten as 7 squared, right? Now, a square root function is actually a half power. So that's x to the 1/2 power. So what's really happening here is this root function right here, this half power is a half power. And so what's happening is you're multiplying a half power times 2. You're taking half of your square power, and you just get 7 to the 1 power, which is 7. And that's why the root disappears. This is what they are asking me. Okay, so now what this is we call this completing the square in order to put circles in standard form. So the form that you see right here is general form. That's a general form for a circle, not standard form. So what needs to happen is, in order to find the center of the circle and the radius of the circle, you're going to complete the square in order to put it in standard form. Now, standard form is this, where you have x minus h quantity squared plus y minus k quantity squared equals r squared. Now, that's the form we want because that's going to give us our center and our radius. Now, there is a step to doing this. Now, before we do this, I want to just review a few things. Number one, I want to review how to find, how to complete the square. So let's think about that, okay? If I had a number like, let's say, x squared plus 6x, in order to complete this square, okay, you're going to go through a couple steps. Number one, you're going to take half of the b term. Now, a lot of people will ask, what's the b term? Where does that come from? That comes from y equals ax squared plus bx plus c. This is a standard quadratic. There's your b term. B term is in front of x. Okay, and so you're going to take half of the b term, and then you're going to square that. So half of the b term is 3. 3 squared is 9. That's what I'm going to add to both sides. Now, what makes this kind of cool, and I'm going to move this stuff down for a minute, is that when I factor this, okay, and it is a trinomial, and I do have both pluses here, so this is going to be plus and plus. X times x is x squared. 3 times 3 is 9. You have forced this to be a perfect square. By completing the square, you have forced this to be a perfect square. And so what that means is these two terms here are going to be the same. And so you can rewrite them like this, okay, as a quantity squared. Okay, let's do this again. Let's do another one. Okay, and so what's going to happen, erase all this stuff, so you're going to have, let's say we have x squared plus 8x. What am I going to add to this? So again, to complete the square, you're going to take half of the b term, which is 8, take half of that and square that. So half of 8 is 4. 4 squared is 16. That's completing my square. I have finished it. It's complete. It's a perfect square, which means that it'll factor into a perfect binomial x plus 4 and x plus 4. What's the same number that multiplies to be 16? 4 times 4. And then you can rewrite that as x plus 4 quantity squared. Okay, so now what we have to do is take this information here and apply it to up here. Because if you notice, not only do I have the x squared and the x, which means I need to complete that, but I have a y squared and a y, which I need to complete that. And in addition to that, I need to move the 30 over to the other side so I can complete those squares. Okay, so let me erase this stuff and get to the problem. So we're done with the review. So I'm going to rewrite this. You have x squared minus 6x plus no value, plus y squared plus 10y plus no value, we're going to get to that value in a minute, is equal to negative 30. So the act of actually having an x squared and an x means I need to complete that square. Having a y squared and a y means I need to complete that square. Meaning if I just had x squared minus 6x and I complete this square, find that number, and then I have y squared and that equals negative 30, I don't have to, there's nothing to complete here because it's done. It's just a y squared. Whereas here, anytime you have an x squared and an x, that means you have to finish that. That means complete the square. Okay, so what we're going to do is we're going to complete the square and we're going to try to put it in standard form. So we're going to take half of 6, which is 3, or technically it's negative 3 with the negative sign. But then when I square negative 3, okay, I'm taking negative 6, divide that by 2, I get negative 3. You're going to square that. So you're going to add 9. In this case, you're going to take half of 10, which is 5. So half of 10 is 5. 5 squared is 25. So I'm going to add 25 here. Now, here's the deal. When you're doing this problem, okay, you should notice that this is an equation. See the equal sign? That's an equation. And what that means is that if you have an equation, that means that whatever you do to one side equally, you have to do to the other. So if I added 9 to the left side, I do need to add 9 to the right. And if I added 25 to the left side, I am going to add 25 also to the right side because it is an equation and I do need to do the same thing to both sides. So let's just simplify. We did completing the square, we completed the square, and now we just need to add these up. Negative 30 add 25 is negative 5, right? So now I have negative 5 plus 9 is 4. So on the right-hand side, I'm going to have 4. On the left side, I need to factor this, and I need to factor this now that I've completed this square. So you're going to say that that's going to be x minus 3 times x minus 3 plus, and then we're going to factor this right side, okay, right here, and that's going to be plus, parentheses, y plus 5 times y plus 5, and that equals 4. And then these two terms here are going to be the same, so I can actually rewrite them like this. X minus 3 quantity squared plus y plus 5 quantity squared is equal to 4. And then what I have now from here, okay, is I have my equation that's in standard form right here, okay? And I have my center, which is going to be positive 3, comma, negative 5. And if I know that r squared is equal to 4, then if I square root both sides, r is equal to 2. And then all I have to do now is actually graph this, okay? And then in graphing this, I have over 3 down 5 and over 2 up to etc. So making a circle like that. Okay, so that's completing the square to find the center and the radius. So in order to do that, let's do that again. So again, what I see is an x squared and an x, a y squared and a y, and then this number here, I want to move to the other side. But in order to do this, you're going to have to complete the square not once, but twice to put this in standard form, this general form equation in standard form. So what I would do is pause the video and try to do this yourself first, and then turn it back on when you're done. So let's get started on this. I'm going to say that's x squared minus 14x. I'm going to complete the square. So I'm going to take half of 14, which is 7, square that, square 7, and, well, negative 7. Negative 7 times negative 7 is positive 49. And if I added 49 to the left side, remember, that's 46 from here. That moved over. I'm going to add 49 to the right side. Now, this one right here is going to be completing the square again for these two, and you're going to have y squared minus 8y. Half of 8 is 4. 4 squared is 16. And again, I'm going to add 16 to the right. So what we're going to do here is we've just finished completing the square, and now we're going to factor, and this side we're going to simplify. So on the left side, we have x in a quantity here. Then we're going to have y in this quantity here. So what times what is x squared? So that's going to be x times x. What times what is going to be 49, but adds up to be negative 14. So that'll be negative 7 times negative 7. For this, we're going to have y times y is y squared. This is a negative 8, but a positive 16. So that means both of those are negative. So I have 4 and 4. And then rewriting these, I have x minus 7 quantity squared plus y minus 4 quantity squared is equal to, now let's simplify the right. We have negative 46 plus 9, which is 3. 3 plus 16 is 19, so this is 19. This is now in standard form. And in order to find the center, I would take the opposite. So it's going to be positive 7, positive 4. And my radius, so if r squared is equal to 19, my radius, after I square root both sides, is going to be the square root of 19, which is about, square root of 16 is 4. So this is going to be like in between. So there's the square root of 16, there's the square root of 19, and the next one we know is square root of 25. This is definitely closer to 4. So I would say that that's like about 4.3. And graphing this, if my center is at 7, 4, I would go over 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. My radius is a little bit over 4. So over 4, 4, up 4, a little bit down here. And then this is what my circle looks like. Two more circle problems. So let's draw this first one. It says the circle has a center at 3, negative 2. So over 1, 2, 3, negative 2. So here's my center of my circle. Okay, it's 3, negative 2. It says that it passes through the point 4, 6. So there's 4, 1, 2, 3, 4, 5, 6. So here's 4, 6. Now, be careful, because what you're doing is that your circle is passing through that, okay? So keep in mind that this circle actually is going to look something like this, because it has to pass through this point, which is at 4, 6. So given that that point is 4, 6, okay? And this is my center at 3, -2. I need the length of my radius, okay? And so what I would need to do is to connect this with this, okay? These two, that's my radius, all right? I do have my center, all right? So let's start writing the equation. Remember, it's x minus h quantity squared plus y minus k quantity squared is equal to my radius squared. We already have half of the problem. We have the center. The center goes in here. So really, it's x minus 3, because this goes with the x term, this goes with y, quantity squared, plus y plus 2 quantity squared. Because remember, given the point h comma k, we have x minus h quantity squared plus y minus k quantity squared. So far, this is what we have. In order to find r, I can either make a right triangle or I can use my distance formula, which I'm going to choose to do. So my distance between the 2 points is going to be the square root of, I'm going to go 4 minus 3, so 4 minus 3 quantity squared, plus 6 minus -2 quantity squared. So this is 1 squared, plus this makes 8 squared, which is 64. 64 plus 1 is root 65. Now, d, my distance or my radius, right, is the square root of 65. So this value is the square root of 65. Super. But keep in mind what I actually need to put in my equation here for standard form. This value is r squared, but what I have is r. So what I need to do with this is actually square it to get r squared, and so this value is 65. A circle has a diameter rs. So let's just make a circle with a diameter rs. So let's see, here's my circle. I don't know where the center is yet. Let's see. Okay. Hard time here making a circle. Okay. I have a, what do I have? rs, r is this value. So if it has a diameter, that means it's going to go through my center. So here's r. And, honestly, I'm just going to redraw this because I really like putting things on an axis. So let's see. I'm going to go back to this equation somewhere here, and I'm going to copy that graph, and I'm going to bring it here because I want to put that here and I want to use an axis. Okay, so here we go. So that's better. So r is at -3, 2. So 1, 2, 3, up 2. Okay, need a pen. 1, 2, 3, up 2. So this is r, okay, and r is -3, 2. And then we have s, which is 3, 2. So 1, 2, 3, 1, 2. Oh boy, this is not that difficult. 3, 2. This is my diameter. And what that means is that if that's my diameter, then my circle definitely goes around like this, okay? And my center, well, the distance between these 2 points is just 1, 2, 3, 4, 5, 6. So at 1, 2, 3, there's my center. Where am I? It looks like I'm at 0, 1, 2. So this point here is 0, 2. So if my center is 0, 2, my radius is 3, because that's this length from here to here. I thought I was going to have to use the distance formula to find that, or the midpoint formula to find the middle. I mean, I could, right? I could use the midpoint, -3 plus 3 divided by 2, which is 0, divided by 2, which is 0. And then 2 plus 2, 2 plus 2 divided by 2, which is 4 divided by 2, which is 2. There's my midpoint. Thought I was going to have to use the midpoint formula, but didn't. So using the equation x minus h quantity squared plus y minus k quantity squared is equal to radius squared, we're going to go x minus 0 quantity squared plus y minus 2 quantity squared. Remember, this is the opposite of k. So if this is hk and k is 2, this is negative 2, is equal to my radius, 3 squared. 3 squared is 9. Just fixing this, a little simplification, we have x squared plus y minus 2 quantity squared equals 9. And then that's my equation in standard form for my circle. Cool. So basically that's it for today. That's the end of day 1, which again includes the introduction to coordinate geometry. It includes distance formula, midpoint theorem or midpoint formula, and also circles, standard form, given the center or finding the center and radius. All right, thank you. I hope that helps.